Hi, my name is Alyssa Uvienko. This presentation is for MCB4934, also known as Data Storytelling in R. I will be applying basic statistical concepts into data given by Whidbey Island Distillery to show the relationships between barometric pressure, alcoholic proof, and temperature using the programming language R. These relationships will be a general overview. More in-depth explanations and information about Whidbey Island Distillery and their unique patent on the continuous still will be provided in the links below. First, we will take a look at our original data. Here we can see that this still has cuts, from the heads to the hearts and from the hearts to the tails. These cuts are made based on their evaporation rates of the specific alcohols such as ethanol and propanol, and are so separated for their certain particular beverage, such as whiskey, bourbon, wine, or other liqueurs. For example, a wine may take hearts, whereas a bourbon would consist more of the tails of the alcohol. And the data I am presenting will be the averages of the heads, hearts, and tails. So now let's examine the data set. So first we will list our data set. And we see that we have a lot of data. So let's see exactly how much by examining the structure of our data set. From here we see that we have 33,794 observations of 3 variables. Even though this seems like a lot of data, it's only a portion. This continuous still produces tens of thousands of data daily. So now we will do some tests independently on these 3 variables. So for the alcoholic proof, it would be very relevant to find the highest proof that we can get from this alcohol. So let's use the max function to find the proof of the alcohol. Dataset of the proof. Okay, so we see that it's 192.35 proof by volume. The next variable I want to look at is the temperature. It would seem necessary to find the lowest amount of temperature to get to our perfect evaporation rate. So we're going to use the min function of our temperature and see what we get. So we get 172.8 Fahrenheit. The next variable I want to look at is barometric pressure. And this pressure really varies a lot according to where you live. So for instance, it would be way different in Florida than it is in Washington, and even different in Whidbey Island. So we're going to actually just use the mean function to see the average barometric pressure that we are dealing with. Okay, so we have 1,110 pascals. So we also want to see how much that varies. We can simply do that by taking the variance of our data set of the barometric pressure, and we find that it's 31.1 variance. So I would say that's very significant. So what we want to do now is see where that lies. Where is the frequency of distribution? So we're going to take a histogram of our barometric data. Okay, so here we're looking at our data set of barometric pressure, and for our x-axis we're going to label it barometric pressure, and for the main title we're going to say the histogram of barometric pressure. So let's see how that ends up, and we see that most of the frequency lies more towards the right. So now we want to see exactly where that mean lies within our barometric pressure. So we are going to make a green line to see generally where it is. And it seems like it's between 1,010 and 1,015 barometric units. So the next thing I think we're going to look at is how this barometric pressure relates to temperature. So we're just going to do a basic plot of barometric pressure to temperature. So here we have now. Our relationship seems inversely proportional. It also seems to be more of a uniform distribution around 1,000 to 1,010 barometric units, and this makes sense because that's where our temperature will evaporate. The next graph I want to look at, or relationship that I want to look at, is how barometric pressure relates to proof. So we're going to make a plot of barometric pressure. So here we have written out data set of the barometric pressure to proof, and we see that it's more of a positive relationship. So as barometric pressure goes up, temperature goes up. So to sum up this, we just analyze how temperature relates to alcohol concentration or proof. For the conclusion of this presentation, I'd like to take a histogram of the proof, since as a general outcome, we would want to know how much alcohol we distilled from our sample and where that frequency lies. So let's make a histogram. So here we have our histogram of our proof by volume. So we see that the majority falls within the range of 186 and 188, and that is very useful to the alcoholic industry. Okay, and now let's see where that mean actually lies with a green line. So it does seem to lie between 186 and 188, which is a pretty good alcoholic proof by volume. Okay, well, this concludes our the presentation. Thank you for listening, and have a good day.